Have you ever been watching a Minecraft speedrun and saw them throw the Eyes of Ender and wonder to yourself, what magic are they doing to find out where the Stronghold is? How do they know exactly where the coordinates of the Stronghold is? Well, I'm here today to show you that it's not magic, it's math. And I'll be taking you through all of the steps on how to do it yourself. So we're just going to start by creating a new world. And while it's loading, I hope everyone is having a wonderful day or night. I don't judge. I don't know where you are. So now that we're in this world, let's just grab some blocks. I like this light blue world. You don't need blocks, but I just like to have them. And of course, it is all forest everywhere. You know what? We're just gonna do this on the trees. 1, 2, 3. You don't need to place any blocks, but I like to. I don't know why. I just do. Anyways, we're just gonna measure where this eye is. So you can see that it's pretty much lined up there. I might just like line it up more, throw more, I guess. Why not? That's like much better lined up. And so now we're gonna look at the information on the screen. The only ones that we care about are going to be the x coordinate, which is negative 161, the z coordinate, which is negative 186, and this angle, which is 154.5. So let's write this all down. So we're gonna take this point here as negative 161.479, comma, negative 186.603. I don't know why I wrote the decimal places. I'm not using the decimal places. 186. I did not like the one. And then we're gonna take straight up to be 180 degrees. And then we know that we're at 154 degrees, which means our actual angle is going to be 154.5, 180 minus 154.5, which is 25.5 degrees. So we can draw this line here, which is 25.5 degrees. Wow. And now we want to turn 90 degrees from our actual angle. So 154.5, we're going to subtract 90 from that, so we get 64.5, so we're going to turn base 64.5 in Minecraft. I'm just going to fly that way for a bit. In an actual speedrun, you would not go this far, but for me, I am just going to, because it increases the margin of error. Well, I actually don't know if that's the right term, but it means that my measurements can be less precise. And so, we have this new point after moving a couple blocks away, and we're gonna mark it down on the sheet. Probably like to go down here. We get negative 212, comma, negative 162, and since we have the normal here, we have a new angle of 156.6. So 180 minus 156.6, 0.6, and that is 23.4 degrees. So we're going to be clicked here with 23.4 degrees. And so now we're going to take the straight edge. I'm going to use my Pokemon card. We're going to connect these two lines here. And I'm just going to extend this. I doubt it'll connect. Because I just don't think. You know what? It's like close enough. Whatever. So, if you remember anything about geometry, then you know that in order to find other side lengths, because we need to eventually find this side length or this side length, we need to have at least one side length. So we can use a distance formula to find the length between our 2 points. So we're going to label this as d. And a quick refresher on what the distance formula is that it's just the square root of x1 minus x2 squared plus y1 minus y2 squared. And so since we have 2 points, we're going to plug that into our distance formula. And so let's put that into our calculator. So that's 1 minus negative 2, so plus negative 186 minus negative 62. And that means that d is equal to 56.364. And that goes on. The full number is in here, but I'm not writing all of that down. So now that we know one side length and one angle, because we know that the distance from here to here is 90 degrees, we're almost close to being able to calculate anything else. So now we either need to find this angle here, which we call theta, or this angle here, which we call delta. And I'll show you how to calculate both. This first angle is theta. If you're familiar with speedruns, they generally subtract the two angles from each other. I think it was, I actually don't remember, it was like, I'll go up to the history, 154.5. So 154.5 minus our current angle, which is 156.6. That gives us 2.1 degrees. So we know that theta is equal to 2.1 degrees. But we can still prove that by the fact that all angles in a triangle are 180. And so while we could just figure this out using that, let's use a different way to find this angle that I think is much cooler. We can take advantage of the fact that this line extends to both of our normals that are pointing the exact same way. A line that bisects another line, both sides of it need to equal 180 degrees. So if we look at this side here, we know that this angle on this side plus this angle on this side is equal to 180 degrees. And we know that this is 25.5 plus 90 degrees. And so we can figure out this angle, which is going to be 25.5 plus 90, 115.5. And so we can find out the other side by subtracting that from 180, which means that it's 64.5 degrees, which means that the angle from here to here is 64.5 degrees. And so to find delta, we know that delta is going to be equal to 64.5 plus 23.4, because we know that it's this angle here plus this angle here. So delta is going to be equal to 64.5 plus 25.4, which is equal to 89.9. Oh, oops, plus 23.4, not 25.4. 87.9. I was about to like flash out because I thought that was wrong, and I was like, how would that be wrong? And then if we just add 90 to that and subtract all of that from 180, we see that we get 2.1, which is exactly what we got before. And so now we can find either of these side distances. I'll show you how to find both because it's pretty much the same thing, but for simplicity I'm going to start by drawing another triangle down here, and we'll add an angle here, which is our 90 degree angle. I don't know why I made that so big. This is our 2.1 degree angle, and this is our 87.9 degree angle, and this length here is going to be our distance d, so that is 56.364. And now if you remember anything about geometry, we know that there's a SOH-CATOA relationship between the trig functions. So SO is sine is equal to opposite over hypotenuse, CA is cosine is equal to adjacent over hypotenuse, and TOA is tangent is equal to opposite over adjacent. So I'm going to just be focusing on the angle 2.1 because I like the smaller angle, and we're going to try to find the hypotenuse, which I'll call H, and the base, which I'll call B. So to start with B, we know the angle and we know the opposite, and we're trying to find the adjacent. So we know that we have to use the tangent. So we can say tangent of 2.1 is equal to the opposite, which is 56.364, over the adjacent, which is B. And if we rearrange that, we get B is equal to 56.364 divided by the tangent of 2.1. And so we can do the same thing for the hypotenuse, except with sine. So we get sine of 2.1 is equal to 56.364 divided by h. So h is equal to 56.364 divided by sine of 2.1. And so that gives us that the base is equal to 56.364 divided by tangent of 2.1, which is equal to 1537.130. And hypotenuse is that divided by sine, which is equal to 1538.163. And those two numbers are pretty similar, but that's what we're expecting because theta is so small, 2.1 degrees. And so now that we know the hypotenuse and the base, we're going to focus on just the base, but we can find the distances from a point to where the stronghold is expected to be. So we're going to use this point here, and we know that we're going to draw a new triangle. So we're going to start with a line, another line, and a third line, because triangles are made of 3 lines. Oops, I hit the camera. This is 90 degrees, and this angle here is going to be our angle between the normal and our line. So we can say that that's 23.3 0.4 degrees. And this distance, the hypotenuse of this triangle, is going to be our base. So the hypotenuse is 1537.13. And so again, to find the x and the z, we're going to label the sides. This is going to be x, this is going to be z. And we're going to use the same trig stuff. So for z, we know that we're going to use hypotenuse, and adjacent, we're going to use cosine. So cosine of 23.4 is equal to z over 1537.13. So z is equal to 1537.13 times cosine 23.4. And the same thing with x, except we're using sine. So x is equal to 1537.13 times sine of 23.4. And if we calculate that, let's see, I'll use the whole number up here, times cosine of 23.4, that is equal to 1410.708. And our x is, if we use sine, so I'm going to put sine in there, and that is 610.467. And so now, one more thing that I'm going to do is I'm going to draw a little compass. So we know that straight up is going to be minus z, and we know that to the left is going to be negative x. And that's important because if we look at here, we're going towards both negative z and negative x. So we're going to say that we need to subtract both these values from our current values. So our x final is going to be equal to negative 212 minus 610.467, and our z final is going to be equal to negative 162 minus 1410.708. And so if we calculate that, negative 212 minus 610.467, we get negative 822. I'm going to round to the nearest whole number now. And if we do that for the other one, one's negative 162 minus 1410.708 is negative 1572. Rounded is going to be negative 1573. So our final expected coordinates are 822, negative 1573. So this is where our guess is going to be. So let's go back to Minecraft and see if we were right. So now I'm just going to TP myself to negative 822, negative 1573, and we are right here. So now for the moment of truth, we're going to go into the ground, and we can see that the stronghold is right there. Wow, look at that. Geometry is helpful when playing video games. Wow, that's what technically said, or something like that. And so that shows that the math is correct, and we found the stronghold using triangulation, which is using trigonometry. And so I hope you enjoyed the video, and I hope that this gave you an insight into the calculations behind what Speedrunners is doing. So thank you for watching, and have a great day.